Let's look at this problem. Find the least positive integer x such that the following holds. X is congruent to 1 mod 2, 2 mod 3, 3 mod 4, 4 mod 5, 5 mod 6. And so what does this even mean? What is a mod? The way I like to think of mods is a mod is just a remainder. So when they say x is congruent to 1 mod 2, that just means that x divided by 2, or I'll write it this way, x divided by 2 is equal to something, like something, remainder 1. And x is congruent to 3 mod 4 means that x divided by 4 is equal to something remainder 3. And we don't really care about something when we're dealing with the mods here. And what really matters is the remainder. So let's look at this problem with what we know now. We want it to have a remainder of 1 when divided by 2, remainder of 2 when divided by 3, 3 by 4, 4 by 5, 5 by 6. Still, it doesn't make the problem a lot easier. So the next thing we do is we work in the modular arithmetic system. And since this is an equation, we can do some tricky things. What's really important here is we can rewrite this entire system. What I'm going to do is x is congruent to minus 1 mod 2. And then x is congruent to minus 1 mod 3. X is congruent to minus 1 mod 4. X is congruent to minus 1 mod 5, x is congruent to minus 1 mod 6. And the way we're doing minus 1 here is because let's look at this remainder again. If something has remainder 1, you can technically write it as having remainder minus 1. So let's say 3, for example. 3 divided by 2 is equal to 1 remainder 1. But you could also write it as something remainder minus 1. You could write it as 2 remainder minus 1. And that still works because 2 times 2 is 4. And if you do minus 1 in the remainder, you still get 3. And so that minus 1 makes this equation really symmetric here because it's all congruent to minus 1, and we have the mod 2, 3, 4, 5, 6. And so now what we want to do is find the least common multiple, the LCM of 2, 3, 4, 5, 6. And what we can notice here is the highest power of 2 is the 4, the highest power of 3 is just going to be 1, 3, and we don't have to worry about the 6 here because that's just 2 times 3. We have the 2 here, we have the 3 here, so let's get rid of that. We don't care about the 2. 2 is encompassed in the 4, and then we have the 5. So the least common multiple of 2, 3, 4, 5, 6 is just 3 times 4 times 5, which is going to equal 60. And so the right answer here is 60 minus 1 equals 59. 59 is the least integer x such that this is solved. And the reason it's 59 is because we have the LCM, and each one of these is going to have a remainder of minus 1.